This problem may look pretty complicated, and it does take some reading to get through, but once you finish reading the first and second paragraphs, what you'll realize is we're describing two sets of numbers. There's the A set and the B set, and each one is just 5 numbers long. These numbers are distinct. In other words, A1 is not equal to A2, and those aren't equal to A3, and so on. And not only are they distinct, but A1 is going to be less than A2, A2 is less than A3, A3 is less than A4, and so on. They're ordered. So these might be 1, 2, 3, 4, 5. They might be 2, 4, 6, 8, 10. Who knows? But we also know that set B has the same values as set A, if you look in the second paragraph, with one exception. That last number in set B, which I've colored in red, is going to be greater than A5. So that's important. I know that B5 is greater than A5. And the question is, what's this going to change in terms of these measurements of mean, median, and mode of A and B? Well, I'm going to go to the obvious one first. If B5 is greater than A5, then that means the sum of set B is greater than the sum of set A. It has to be that way because all the other numbers are equal, except for that fifth number, which is bigger. So if the sum is bigger, and there's the same number of numbers, each set has 5 numbers, that means the mean of set B is greater than the mean of set A. All right? So that's the important thing. First of all, mean is, the way this one's phrased, mean is less for set A than for set B. Okay, great. So I can rule out not enough information given, and I can rule out median only because I just showed that the mean has to be less for set A than set B. I can also rule out mode because that doesn't include the word mean. But let's talk a little bit more about mode for just a moment. Remember what mode means. Mode, in math words, is most common. So if I told you that all these numbers are distinct in set A, that means there's no repeats. That means there's no mode because there's no most common number. So mode is just a red herring in this problem. There's no possibility of even figuring out what the mode is when they're all unique numbers. So my choice is it the mean only, which is going down in set A, or is it the mean and median both? Well, we have to figure out what the median is. And if you remember this part, this is important. The median is equal to the middle of the function. Well, which one of these numbers is in the middle? For the first set, it's A. For the second set, it's A, or A3. And I don't care if B5 is 100 or if B5 is 1,000,000. A3 is still the middle number, right? It's the one that is third in line if you sort them by size. So that means the median is not changing, which means the only thing that's dropping when you compare set A to set B is mean. Mean is lower for set A.